The most important thing to know about muscles is that they can only ever get shorter. Once you intuitively understand this, anatomy becomes so much easier, because then instead of simply having to memorize a bunch of weird Latin or Greek names, you can think about what kind of muscles would you need to perform this task, and in a lot of ways you'll be somehow correct if you just were to intuitively try to figure this out. For instance, let's say we have this skeleton here and we need to move this all the way up. Imagine all the bones here are connected and all that. They're not just going to fall to the ground. So we need to make the skeleton go from here to like out like so. The hand is going to go from here, so the hand is like up here. How would you do that? Just purely mechanically. Well, one way to do this would be to attach some rope here to down there and just draw like a line between it like so. So once you have this line, what you can do is you can just make it shorter. If this line here is going to get shorter, well, you're just pulling this stuff up, right? Now, the only thing that's going to happen is this line here is going to go from like this, and it's going to go out like so. And that's exactly what happens with the bicep, which looks like this. And this is exactly what's going on here. We basically have one piece of string that goes from here to here, and then it has some mass to it, and then this gets shorter, which is awesome. It means that we can very easily start to think about the body in like very mechanical terms. Now, what if we want to make it go the other way? Now, let's say the arm is like out here, and we want to extend this arm. We want this to be straighter like so. Well, like we mentioned, a muscle can only ever get shorter. It cannot get bigger. So it cannot get longer, extend. This is not like the pistons you're seeing, like the hydraulic pistons that can go in and out. They cannot push both ways like this. This can only get shorter. This is a string that can go from this to this. So what do? You probably need some kind of rope from around this region here to here. Notice there's like a nice little lever here. That's pretty handy. So we can put it from here, and we can just make this nice little string go from here and then down here. And now we have some kind of force that we can use. So if this string here were to get shorter, you would now extend the arm. You can think about this. Then the arm would go from the current position to this position, like so. So it would just be like perfectly straight, like so. And this is a very important point in anatomy. The muscles will work in pairs. If you want things to go one way, you need muscles to make it go that way. And if you want something to go the other way, you need muscles for that. In this case here, this is the bicep and the tricep. So here we have one muscle to make it go up, and then we have one muscle to go down. If you've ever been to the gym, this kind of stuff becomes more intuitive as well. You have to think about stuff in real world terms and not just in like abstract theoretical terms like just muscles and origin assertions and such. If you've been to the gym and you want to do bicep curls, what you do, you basically just put the dumbbells in your hand and you just basically lift them up like so. If you're doing anything with a tricep, you're doing the opposite. You start off here and then you push downwards. The force is going to be downwards like so. So this kind of stuff kind of makes sense. So this is incredibly important to understand, because now you'll more intuitively understand anatomy instead of just memorizing some like weird names. Now you can always think about, if there is a muscle here, where's the other one? Where's the one doing the opposite? For instance, if you have like the abs going like here and you need this to do a crunch, all right, cool. What happens if you want to do the opposite, right? If you want to, now you crunched, what if you want to uncrunch yourself? Probably going to be some muscles doing the opposite thing here. So muscles will work in pairs. Another fact about muscles is that in nearly all cases, they are going to be attaching to bones. See here? Point a bit and point a bit. And this is where it attaches. It connects from up here and it connects down here, and it connects from bone to bone. There are some rare cases where it does not connect directly to bone. You might have some fascia and some other things, but it's true enough to say, back to the true enough chapter, it's true enough to say that muscles will always attach from bone to bone. And it's just a very mechanical thing. But the muscle doesn't directly attach to it. And in order to understand that, we have to understand a little bit more about muscles. So the structure of a muscle is that we have two main components of it. We have the actual like belly of the muscle. Just gonna draw this in nice pink colors. We have the main belly of the muscle that goes like so. And then we have the tendon of the muscle. And this is the part that goes out of the muscle like so. The tendon is basically like a piece of string that's attached to the muscle. Now, while the muscle itself, like the body of the muscle, this part here, does get bigger and smaller, like in quite large ways. So you think about this when the bicep is flexed versus non-flexed, it's a very different shape. While these guys do really flex, the tendons don't really flex or contract. And it's really important to think about the tendons as well, because people tend to always push the, think about the shape of the muscle instead of thinking about the shape of the tendon. For instance, here, if you were to not think about the tendon, you just think about the muscle. What you would be then doing is, you know that, let's say it goes from up here to down here, you'll be doing this. You'll just be drawing this shape here and making this go all the way and like all the way down here. And this will be incredibly wrong and it will just look really, really weird. For a lot of muscles, the tendon isn't really something you have to keep in mind because the tendon might be really short or it might be covered by so much other stuff. But in a case like this, it's really important. In a lot of cases, you can also see the tendon directly as well. For instance, yeah, this is very prominent down at the Achilles as well. So like this here, for instance, this is where you have this is called the gastrocnemius. We'll get to that in the legs chapter. But here we have a giant tendon. This is like the most prominent tendon in the actual body. So tendons are incredibly important. So muscles will attach to tendon, which will then attach to bones. And then the final thing about muscles that we have to understand is that muscles do attach from bone to bone, but from specific points in the bone. So in this case here, for instance, we have the deltoid, and this attaches from up here to down here. And this means this is the origin point up here, and then this is the insertion point. You can think about origin and insertion as start and end points. Every single muscle is going to have an origin point, and every single muscle is going to have an insertion point, the start point and the end point. And this makes anatomy a lot easier, to be honest. It sounds like it's a lot of information. Now you have to memorize the origin and insertion point. But this means that you have more of a recipe for how this works instead of just going in and approximating where it goes from and to. No, now you have a highly specific point where this goes from and to. For instance, this is a muscle in the neck. You could feel this on yourself if you like move the head to one side. Now you can really feel this. It's quite a prominent muscle. This one here has an origin point here, and it goes to this point, and it goes to this point. And this gets quite simple to understand once you know about these points. Essentially what you're doing, you're just making little dots, and then you're just memorizing the dots. So instead of having to memorize the whole thing, you can essentially just do one point and just draw a line between these two, and then you can just basically just sort of like draw some volumes between these two. This is how you can really simplify muscles, and this is like true enough. Let's say you have the pecs, for instance. The pecs will go from here to here, and then it will go from like here, this ridge here, to like here, and then from like here to like up here. And now you can simply just add lines to these, and then you can add volume to these lines. This becomes really effective. So simply just thinking about muscles as origin and insertion points becomes very, very, very powerful. So that's really muscles for you. To sum up the whole thing just in very short ways, a muscle can only contract. Muscles are going to work in pairs, or at least you're going to have opposite forces. Muscles attach to tendon that attach to bones, and every single muscle is going to have an origin and an insertion point, a start and an end point.